So coming forward, we are going to explore the new thing, the concept of classification, like binary classification, and we have a lot of different techniques that we use in the binary classification. So firstly, we'll go through some of the basic concepts of how things used to be in this domain, or this thing, or this technique specifically. So previously we used to use simple for loops when you're having the neural networks to iterate over that, but what we are going to have is the having entire for loop for the entire thing, so not to break the whole data into the smaller segments. So that's how we are going into the logistic regression part. So for that we are going to use and understand the forward pass, forward and backward pass, and why is that there, why forward pass is there, why backward pass is there, and we're going to use logistic regression. In terms to understand in terms in the ways to understand the binary classification. So let's dive in, guys. So let's delete all these things. So first of all, let's suppose one is going to be there when the image is of dog, and 0 is going to be there when the image of cat, I mean the image is not of dog. So that's what we will call our function y. Alright, so we have to keep this in mind, and after that what we are going to understand is we convert each and every pixel into the form of matrices. So these are going to be 64 by 64 matrices, like red, green and blue, and we are going to transform them into the feature vector, where we are going to take each and every number. So whatever the numbers are in the red matrix, we will be writing those numbers. Once the red matrix numbers are over, we will be writing the numbers from green matrix. Once those are over, we will be writing the numbers from blue matrix, and that's when we are going to get the feature vector. That's the feature vector, and the total dimension for this feature vector will be 64 into 64 into 3, which will be the number 12288. That will be the number of dimensions we will be having in the gravity. So what we will call brevity is this notation, and the number of dimensions will be an x equal to 12288. That will be the whole thing. And what will we be calling feature vector is x, and what we will be calling y is the previous thing what we kept y as. So I hope you guys know what y is. That is just the thing, 0 or 1. yes or no. So that's what we are going to write. So I hope the notations and the concepts are clear until here. So let's dive further. So let's suppose we have feature vector x with the y, x and y, where x is the dimensional feature vector in the single training example, where y has the aspects 0 and 1. So this is for single example, and when we are thinking for m training examples, then it will look like x, x1, y1, x2, y2, and this will go on until xm, ym. So this will be our entire training set, the whole thing, and yum will be the number of total training examples. So we can put m in the notation as m train for number of training examples, and we can put m for m test for number of testing examples. So finally, to put all the training examples into compact notation matrix, we will be using capital X. So we have to keep this thing in mind. So just keep all the notations in mind, alright? So what we are going to do now is we are going to check that X here, and we are going to create one compact matrix where we are going to keep x1 here, we are going to keep x2 here, where this matrix is the number of training examples. So these are the number of training examples, x1, x2 up to the xm, and we'll call this as m, and we'll call this as nx. So these will be, nx will be number of rows of the height of the matrix nx. Alright, and you guys will be noticing that a lot of courses or a lot of people are teaching the way to do the same thing in the transpose way. So they will be taking x1 transpose, then x2 transpose, and up to the xm transpose, but that makes things complicated, so we will not use that. We will be going to use this way instead. So x will be we can denote x as nx times m. That is, we can write that in Python as x dot shape equal to n, this is subscript, so nx times m. So remember guys, this is subscript. I'll just write that with pen, so that will be easy. So this is nx, so this is the same thing, nx times m, and That is the whole thing behind it. So that is the group training example. Input x into the matrix and output level y. So what we are going to do with the output level y. So the thing about x, we understood the thing about x now, but what about y? So we will do the same thing with y. We are going to stack y in the columns y1, y2 and y until ym, where y will be equal to 1 times m. So we can write that just like y y.shape equals 1 times m. That's how we'll write it in the Python, which means 1 comma m in the matrix. So you guys will be understanding the whole concept and whole applications of all these notations and concepts in the further part of the course, but I hope the concept is clear until now. So these are really important concepts when we are going to program binary classification using logistic regression, and I hope you guys understood this whole thing, and thank you and see you guys in the next one.